Hello, welcome to Advanced Algebra 2. Today we're going to take a turn away from parabolas, which is a little tricky because they themselves turn around, but if you turn twice, the parabola can't follow you. And we're going to go back to lines, and that's nice because it'll go forever, but don't worry, the unit won't. We're going to talk about how to cross lines. This is definitely a review topic from Algebra 1. There's a tricky bit of business at the end. There's some secret shortcuts I'm trying to help you out with in the middle. You might already know them. And let's see what we got. So here we got our first example. It says use elimination. And elimination is also called linear combination, but it's the magic thing where you multiply both equations and make things magically disappear, like, I don't know, whatever it is that disappears. Okay, so first of all, I've got this system of equations. The first line is 3x minus 7y equals 31. The second line is 2x plus 5y equals 11. I rewrite it because I'm going to mess with it and I want it to know that I'm the boss. So go ahead and potentially, if you wanted, you could multiply the first equation by 5 and the second equation by 7. And if you do that, you got to remember everything in the first equation multiplies by 5, including the constant at the end, and everything in the second equation multiplies by 7. Again, that includes the constant at the end. And the reason for this is that when you add them up, you get 29x, and then the y's are gone, bye-bye y, and 29x equals 232. That's why we chose the 5 and the 7. And then divide by 29. I mean, it's kind of quick order of business here. And we're seriously almost done. We got x equals 8. Feeling good. We're like, yeah, I got x. I'm done. And it says, no, you're not. You got to go back and get y. So the most common way of doing this is to grab one of the equations. It could be an original equation. It could have been one of the ones after you multiplied, and it does not matter which one. Here I chose the second original equation, and then substitute that actual number in that you just got. So he said x is 8. It's like, okay, well, if x is 8, then I'm going to make x 8. So I'm really talking about 16 plus 5y equals 11. And in that case, you move the 16, and you got 5y equals negative 5, and then boom, you divide by 5, you got y equals negative 1, and you're like, ha, I'm better than getting x, I got y, I'm done. And no, you're not, but you're really almost done. You need to go ahead and write your answer as a point, because these are two lines that indeed cross at the point 8, negative 1. Yay! Okay. Next example. Similar thing, but there's a reason for this. So even if you you got the first thing, you're like, oh, that's obvious, great. It's worth paying attention to what's going on here. So here, you probably can get away with just multiplying the second equation by 3. And that brings up the coefficient of y to negative 3y. I guess that's bringing it down, not up. But either way, when you add the two equations, the original first equation, along with our modified second equation, you got 19x equals 31. And the y's gone, bye-bye y. And so then if you divide by 19, you got x equals 31/19. Oh well, it's a number's a number. Okay, you could totally do what I showed last time. You could take x, substitute it into any of your favorite equations, and rock it out. And in the days of kind of modern calculators where the calculator screen will show you what you're doing, there's nothing wrong with that at all. It's just fine. But I will warn you that there were days before modern calculators, and they were dark times for all of us. And it was kind of annoying to deal with fractions in those cases. Now it's just kind of emotionally annoying for you, but beforehand it was actually logistically annoying too. So, you had to actually multiply numerators and denominators. It was just bad. So a way of dealing with this, I'm going to show it to you. You're never really required particularly, but you should notice, is to kind of redo the problem. The first time, though, we eliminated y, and that way we were able to solve for x. That's what happened on the left. On the right, though, I'm going to do the opposite thing. I'm going to eliminate x. so I'm going to multiply the top equation by 5 and the bottom equation by -4. And that makes you got 20x, and you got 15y equals 50. Remember to multiply the constant. You got -20x, and you got plus 5y, and you're talking about -28. Whatever. Add them up, and this time bye-bye x, 19y equals 22. Divide by 19, you got y equals 22/19. And now you can just write the answer. So you totally could have solved this problem by doing the stuff on the left and going back to substitute in, or frankly doing the stuff on the right and going back to substitute in to get the other variable. Or you can just kind of eliminate once, take a little break, and eliminate the other side, and then you're done. All right. Well, okay. Third example. Here we have something different going to happen, and in fact, you might already notice what it is. There's no problem here. It's kind of obvious for the people who know what to look for, and hopefully at the end you will also know what to look for if you don't already. So I'm going to be manipulating these equations, so I insist on rewriting it. I don't really care if you do or not. If you take that top equation, you multiply by -2, this way you'll see the x's will line up, right? Because I got -6x now for the x coefficient, or -6 is the x coefficient, and 6x for the, for the x coefficient, 6 for the x coefficient on the second equation. And now when you add them up, the x's are gone. You're like, bye-bye x. Oh, bye-bye y too. Bye-bye constant. It's all gone. You got 0 equals 0. And the truth is, if you end up with 0 equals 0, you should be happy. So I'll draw a little happy face. Someone's wearing glasses or something. Hey, because when that happens, that's infinite solutions. That means, boom! So many solutions you can't possibly fathom it. And in fact, that's because they are the same line. I'll speed up a little bit. They are in fact the same line. And if you look, the second equation is just what you get if you multiply the first equation by 2, right? If you multiply 3x minus 7y equals 31, the top equation, by 2, you end up with 6x minus 14 equals 6. You get the exact same thing as the bottom equation. There's a special word for what's going on here. It's called dependent. I'm not huge on vocabulary tests and that sort of thing, but, it's a thing to know, and you should be able to recognize what that means when that's, listed in a set of directions or a set of options, that sort of thing. All right, so dependent is the magic word for what's going on here. The magic reason is that they're the same line, and the 0 equals 0 is your sign that that happened. All right. Fourth example. This looks a whole lot like the third example, but there's just a little difference here. So you got 3x minus 7y equals 31, and then the second equation is 6x minus 14y equals -62. Yeah, okay, I can see that. Now, if you multiply the top equation by -2, which again, the purpose being to be able to eliminate the x's, -6x plus 14y equals -62. That 14 is just a little bit on steroids because I actually did this wrong the first time and I had to rewrite it, and then I wasn't in the same handwriting mood. Hey, look, I'm talking and things are happening. Hey, if you did the first equation by -2 and then you just kind of leave the second equation, then the x's go away and the y's go away, but the constant, the number on the right side of the equal sign, that doesn't go away. That makes me sad. And in fact, that's because you have no solution. So if you kind of scan back on example 3, it was 0 equals 0. That's infinite solutions. You have no variables to solve for, but it's okay because it's nothing. Here you have 0 equals -124, and you're like, not even when there's a full moon is 0 the same thing as -124. So no solution. The lines are parallel, in fact, and I'm going to show you here. The arrangement between the x's and the y's is the same on both of them, right? Like if you ended up solving for y, you would end up with 3/7 as the slope in both cases. But they have different y-intercepts. And remember, that's about the arrangement between the y coefficient and the constant. So, on the top one, the y-intercept is -31/7, and on the bottom one, the y-intercept is positive 31/7. It doesn't really matter what the numbers are, but they end up being different. So, if you want to convince yourself of this, you could take each of those equations, original equations, and solve for y, like you're just going to do slope and intercept all over again. And you would see, like, it's the same slope, so they're parallel. Okay. This is also called inconsistent. So if you need a magic vocabulary term to help you through these dark days of no solution, the magic word is inconsistent. And I'm writing too slowly, so let's speed it up. Okay. Now, we've had first example, very straightforward. Second example, could be straightforward. I was trying to show you a trick on what's going on when you have an option to eliminate twice instead of eliminate and substitute back. Third example is that infinite solution thing. Fourth example, no solution. It's worth making sure you know the difference with what's happening between those two things. It's not the hardest thing I'm going to ask you all year, but it's a thing for some people. Now, the fifth example, this is where you just might want to cry when you look at it, because you're like, but there's not x's and the y's. I mean, there are x's and y's, but they're not where they belong. Oy vey. Okay, so again, I demand that I rewrite the equations because I want to show it who's boss, basically. Before we get excited and multiply, I'm going to separate each of the fractions. So 3 over x is going to be 3 times 1 over x. 6 over y is going to be 6 times 1 over y. You may very well find some shortcuts for yourself through this. There's no reason not to do that. Go ahead. But I'm going to kind of show it a long way, at least for this first time. Okay, so we've got it written out, and now it looks a little bit better because it's a coefficient times a variable thing plus a coefficient times a second variable thing equals a constant, both top and bottom. And that's great, but they're still not what they should look like. I mean, the variables are 1 over x instead of x, and 1 over y instead of y. So a way of cheating your way through this is to just make new variables. And this is a trick that you will see happening with increasing frequency in your life. So instead of writing 1 over x, I'm going to write a. And instead of 1 over y, I'm going to write b. Because that makes this look so much better. See, you got 3a plus 6b equals 1. You got 3a plus 7b equals 2. And now this looks almost like, a sane thing to do. This is ready to go if you subtract instead of add. And if you don't like subtracting, you could multiply by -1 and add, or, you got options. But if you subtract, the a's go away, bye-bye a's, and the b's, well, not quite. You got 6 minus 7, so -1b equals -1, and then b is 1. And that's great, except that's only half of an answer. So you gotta substitute it back. You could, of course, eliminate a second time with the b's, but it's a little more annoying. You have to multiply both, 7 and a 6, whatever. Anyway, you substitute in the 1 in this case. So you got 3a plus 6 equals 1. If you move the 6, you got -5. And if you divide by 3, you've got -5/3. Okay, so b is 1, a is -5/3, and you feel like, I got both variables, I'm good to go, I'm done. And the answer is, no, you're not. And you're like, yeah, I know, I got to write it as a point. I'm like, no. If you look back at the original problem, the variables aren't a and b. A and b are some made-up stuff you did earlier in life. So you need to take this a and b information and get back to the x and the y. So here's what we're going to do. A is -5/3. It says so, over there. But a is the same as the reciprocal of x, and so -5/3 is the reciprocal of x. Now, I'm going to show a quick flippity-floppity. Since it's the reciprocal, you can just reciprocal your reciprocal and get back to x. If you don't like that I went really fast at that last arrow, you can totally do that little Algebra 1 thing, or actually 7th grade math thing, where you cross-multiply. So you -5x equals 3, and then solve. It'll totally work for solving proportions with cross-multiplying. Totally doable. But hey, x is -3/5. Okay. Second one is b equals 1. But wait a minute, b was the reciprocal of y, so it's 1 over y. So 1 is the reciprocal of y. This one is actually so easy, it's kind of hard. If 1 is 1 over y, that means y is 1. remember I said above on the x's you can just turn it upside down, and you totally can. Negative 5/3 turned into negative 3/5. Well, 1, if you turn it upside down, is still 1, because it's really like 1 over 1. And then if you flip it upside down, that's 1 over 1. Wow, as I say this, I understand why people enjoy how you can make me stop talking during the videos. Anyway, the other piece of good news is that we're pretty much done. We've got an x value, negative 3/5. We've got a y value, 1. That's it. That's the last example. There's a set of book problems I'm going to ask you to do. And I am going to actually stop talking whether or not you stop the video. So thank you for watching. Please let me know if you have any questions. Goodbye.